May 24th, 1941. The Denmark Strait. A colossal pillar of fire erupts from the midsection of HMS Hood. A blinding flash, a column of smoke soaring thousands of feet. And then, nothing. The ship, the largest and most famous warship in the world, is gone. Her bow section rises vertically from the water as the stern disappears. 3 minutes later, the sea is empty, save for 3 survivors. She was the pride of the Royal Navy, a 48,000-ton symbol of unrivaled sea power. Yet, when she finally met her intended match, the German battleship Bismarck, the duel lasted just 8 minutes. How could a vessel designed to rule the waves, the very image of indestructibility, be annihilated by what was likely a single, lucky shell? What catastrophic engineering flaw lay hidden beneath her decks, waiting for that one-in-a-million shot? This is the story of the mighty Hood and the strategic flaw that sealed its fate. We will dissect how it was designed and why it failed. To understand Hood's fatal weakness, we must go back 25 years before her duel with Bismarck, to the smoke-filled skies of the North Sea. The year is 1916. The strategic problem facing the Royal Navy is the German battlecruiser. These fast, heavily armed ships are commerce raiders, able to outrun any British battleship and outgun any British cruiser. The British solution, championed by the aggressive Admiral Lord Fisher, was the battlecruiser concept. Fisher's doctrine was built on a simple, brutal mantra: speed is armor. He envisioned capital ships with the devastating 15-inch guns of a battleship, but the hull and engines of a much lighter, faster cruiser. Their purpose was not to fight in the main battle line against other battleships, but to hunt down and annihilate their German counterparts. HMS Hood was conceived as the ultimate expression of this doctrine. She and her Admiral-class sisters were designed to make over 31 knots, a staggering speed for a ship of her size, while carrying 8 massive 15-inch guns. But just as Hood's keel was laid, the Battle of Jutland provided a horrific proof of concept for this design philosophy. In a single afternoon, 3 British battlecruisers, Invincible, Indefatigable, and Queen Mary, were obliterated, destroyed by magazine explosions initiated by plunging German shells. Their high-speed, light armor design had proven suicidal in a stand-up fight. A wave of panic swept the Admiralty. Hood's design was drastically revised while she was still under construction. Over 5,000 tons of additional armor were added, thickening her main belt and turret faces. Her displacement swelled, making her a true colossus. But these additions were a patch, not a cure. She was now a compromised vessel. She was too slow to be the pure hunter-killer she was meant to be. Yet her original 1916-era deck armor, designed only to protect against the glancing, low-angle fire of a cruiser chase, was left dangerously thin. This was the compromise. The Royal Navy, desperate for a symbol of power, rushed her to completion. Hood entered service as a hybrid, a ship with the armor layout of a World War I battlecruiser, but the size and expectation of a World War II battleship. She was the most powerful warship afloat, but buried deep in her design was a flaw, a legacy of a doctrine that had already been proven fatal. When we open up the Hood in our 3D analysis, her sheer scale is breathtaking. At 860 feet, she was nearly 100 feet longer than her adversary, Bismarck. She was a machine of superlatives. But as we peel back the layers, our analysis reveals a ship of profound contradictions, a titan of firepower built on a fragile foundation. First, the firepower. Hood's primary weapons were 8 15-inch 381mm guns, housed in 4 twin turrets. These were among the most reliable and powerful naval cannons ever built, firing a 1,920-pound armor-piercing shell to a range of over 16 nautical miles. In our cross-section, we can trace the complex machinery of her magazines and shell-handling rooms. Deep below the waterline, cordite propellant charges and massive shells were hoisted up to the breeches. This entire system, the guns, the hoists, and the magazines, formed the ship's vital core. Second, the speed. To understand Hood, we must visualize her engineering spaces. They are vast, occupying nearly a third of her hull. Here, 24 Yarrow water tube boilers generated superheated steam, feeding 4 massive Brown Curtis geared steam turbines. This plant produced 144,000 shaft horsepower, driving 4 propellers to push the 48,000-ton vessel to an incredible 32 knots. This was her battlecruiser DNA, the speed as armor concept. But this speed came at a cost. It required a long, fine hull, which in turn created a massive, elongated target area that needed to be protected. And that brings us to the protection, the tragic flaw. Here, our forensic model shows Hood's armor scheme. It's a patchwork, a relic of her 1916 design, compromised by the lessons of Jutland. Her vertical protection, the 12-inch thick, 305mm main belt running along the waterline, was formidable. It was even angled outwards at 12 degrees to increase its effective thickness against a direct, horizontal hit. The danger in 1941 was not a horizontal hit. Naval gunnery had evolved. Engagements were now fought at extreme ranges, over 20,000 yards. At that distance, shells don't strike the side of a ship. They arc high into the sky and plunge downwards, striking the deck. And Hood's deck armor was catastrophic. As we trace the layers, our analysis shows the main armored roof protecting the magazines and engines was, in most places, just 1.5 inches thick. This was supplemented by an upper deck, also around 1.5 to 2 inches thick. In total, her all-or-nothing protection was a thin, layered system designed to stop shells from light cruisers, not a 2,000-pound battleship shell. Over the aft magazines, the ship's most volatile area, the total horizontal protection was at best 3 inches, 76 millimeters. This infographic shows the trajectory of a Bismarck 15-inch shell, fired from 18,000 yards. It descends at an angle of over 40 degrees. Our analysis confirms that at this angle, the shell would not even register the 1.5-inch upper deck. It would slice through it, and then easily perforate the 1.5-inch main deck below before exploding inside the ship, right above the magazines. She was scheduled for a massive refit in 1939, a refit that would have finally added the necessary 3 inches of solid plate over her magazines. The war started first. The Royal Navy's greatest symbol was sent to hunt its most dangerous enemy with a fatal 25-year-old vulnerability. The Denmark Strait, 0549, on May 24, 1941. The sea is heavy, the sky a dull gray. Vice Admiral Lancelot Holland, aboard Hood, has maneuvered his 2 ships, Hood and the new battleship Prince of Wales, to intercept the German squadron. At 0552, from a range of 25,000 yards, Holland gives the order. Hood's 15-inch guns roar, opening the Battle of the Denmark Strait. But the first mistake is already made. Holland's flagship mistakenly targets the Prinz Eugen, the smaller German cruiser, leaving the Bismarck unmolested. At 0555, the Germans return fire. Their gunnery is precise, methodical. Both Bismarck and Prinz Eugen concentrate their fire on Hood. On their second salvo, Prinz Eugen lands an 8-inch shell. Our 3D model shows this hit on the boat deck, starting a large, fierce fire among the ready-use ammunition for the 4-inch anti-aircraft guns. Hood is now on fire, a visible burning target. Admiral Holland knows his ship's vulnerability. He knows that at this long range, he is in the plunging fire zone. His only chance is to close the distance, fast. By running towards Bismarck, he can force the shell trajectory to become flatter, until the shells strike the Hood's mighty 12-inch belt armor, not her paper-thin deck. He orders a 20-degree turn to port to bring his aft turrets to bear. It is 05:59. Hood is in the middle of this turn. The range is approximately 18,000 yards. At this exact moment, Bismarck fires her 5th salvo. Here, our forensic recreation begins. We trace the path of a single 1,760-pound, 800 kilograms armor-piercing shell as it leaves Bismarck's main gun. It arcs over 10 miles high, traveling for nearly 40 seconds before descending at a steep angle. At 06 o'clock, that shell arrives. Our analysis of the wreckage and eyewitness accounts pinpoints the impact area. The shell strikes Hood on the starboard side, aft of the mainmast, in the exact area that the 3-inch deck armor was supposed to protect. The shell's journey is visualized here. First, it strikes the 1.5-inch upper boat deck. The hardened steel cap of the shell barely registers the impact. It punches through instantly. It continues its descent, passing through unarmored compartments. Then, it strikes the 1.5-inch main armored deck. This was the last line of defense for the magazines below. The shell, still at high velocity, perforates it without effort. The shell's delayed action fuse, designed to detonate after piercing armor, now functions perfectly. It explodes deep inside the ship, in the worst possible location. The handling rooms and magazines for the aft 15-inch Y turret and the 4-inch secondary guns. The resulting detonation is not an explosion. It is a deflagration. Over 112 tons of cordite propellant ignite in a fraction of a second. Our 3D cross-section shows the physics of this event. A pressure wave of incandescent gas, expanding at thousands of feet per second, seeks the path of least resistance. It travels upward, bursting through the decks and launching the 15-inch X turret into the air. It travels downwards and outwards, ripping the hull apart. The ship's steel spine, the keel, snaps. Hood is broken in two. The pillar of fire seen by Prince of Wales is this propellant gas venting vertically, a catastrophic blowtorch. The aft section sinks almost immediately. The forward section, its internal bulkheads collapsed, lurches forward on momentum alone. It rears up, bow vertical, and then slides backwards into the ocean. By 0604, it is over. The mighty Hood and 1,415 men are gone. The entire engagement, from first shot to final sinking, lasted just 8 minutes.